Uh, Hello guys. So now we'll discuss what is dielectric constant. Dielectric constant. So I think most of you already have known that what is dielectric constant, and you also know um, how to calculate those things. But the most important point is why we have defined such type of constants. That is the very important thing. You should understand why these parameters are very important. Okay, you should appreciate those quantity. So let me tell you what is dielectric. In the last class we saw, in the last video, we saw that if we have an electric field, let's say this is an external electric field, this is an external electric field. Now let's say the magnitude of this electric field is E naught. This is my applied electric field. Okay. Now if I will place one dielectric material inside this electric field, then what will happen? Then we know, then there will be some induced charge, right? So you can see in the left hand side we will have some negative charges, and in the right hand side we will have some positive charges, and hence there will be some electric field in the opposite direction, that is this one, right? And this electric field is known as electric field due to polarization charge. Let's say this is EP, its magnitude is EP, that is electric field due to polarization. Okay, now in the forward direction we have E naught, in the backward direction we have EP. So the resultant field inside this dielectric is, let's say, E, and how much it will be? E will be equal to, E vector is equal to E naught vector plus P vector. Maybe you people are thinking that I should give negative, right? But here I have written E naught vector plus EP vector, where EP vector is a negative thing, whereas its direction is opposite to the direction of applied electric field. So if we see, then you can say that the magnitude of E vector will be less than magnitude of E naught, right? Because we are subtracting EP, because EP is in the opposite direction. Okay. Now, if E vector, that is the electric field inside the dielectric, is less than E naught, then we can say let's say the electric field E equal to E naught by K. That means I am defining some constant K, which shows that, let me write K equal to E naught by E. That means how much fraction, like it's showing that how much fraction the electric field has reduced inside the dielectric, and this constant is known as dielectric constant. So what is dielectric constant? It's showing that how much the electric field has changed, due to the dielectric. So it's just a ratio, right? So whenever someone told you that the dielectric have some dielectric constant of 1.5, that means you know that the electric field would have reduced in that much amount, with that fraction. Okay, so this is known as dielectric constant. Okay, now again let me write this expression. If we can write E equal to E naught by K. Again, if I write the value of E naught for the point charge or something like that, I can write this one as 1 by 4 pi epsilon naught Q by R square, right? If I am writing this E naught for the point charge, and here it is K. So this electric field can also be written as 1 by 4 pi epsilon naught K Q by R square. So electric field inside the material is 1 by 4 pi epsilon naught K Q by R square. So this is the electric field in a dielectric when the source charge is a point charge, that is like this. So this is the point charge, source charge, and its electric field is like this, right? And suppose here we have the dielectric material and you are finding electric field inside this one. Okay, so because of this point charge q, we'll have applied electric field in this direction, and the electric field due to polarization will be in the opposite direction. Okay, so the electric field at this point is equal to how much? E can be written as 1 by 4 pi epsilon naught q by r square divided by k, if the dielectric constant is k. So it is 1 by 4 pi epsilon naught k q by r square, right? So this is the expression for electric field inside that dielectric. But again we know in the first formula we told that E can be, in general, using Coulomb's law we have written that E can be written as 1 by 4 pi epsilon naught q by r square, and this is for free space. And if there is some defined medium, like if there is some dielectric like this, and if it's the permittivity of this medium is epsilon, then we can write electric field at this inside this dielectric will be equal to E equal to 1 by 4 pi epsilon naught 4 pi epsilon q by r square. And what is epsilon here? Epsilon is the dielectric of the medium. The epsilon is the permittivity of the medium. Okay, like epsilon naught is the permittivity of the free space. Similarly, epsilon is the permittivity of the medium. Now let's compare these two. In the second expression, this is the expression of electric field, right? This is the expression of electric field inside that dielectric. And here again, this is the expression of electric field inside the dielectric. If we compare these two, then you can see epsilon equal to epsilon naught into k, right? So we can say k equal to epsilon by epsilon naught. That means what is k here? Again, k is showing that how the permittivity of the medium, like how much fraction is the permittivity of the medium with respect to the permittivity of the free space. That's why k is also known as relative permittivity of a medium. That means what it is saying, like how much it is, like what is the fraction of the permittivity of that medium with respect to air. So it's telling about that. Okay. Now we know that k is known as k is known as relative permittivity of the medium, and also it is known as dielectric constant. And here epsilon naught is the permittivity of the free space, and epsilon is the permittivity of the medium. Okay, so now you can feel that what is the meaning of k and what is the meaning of epsilon. Like whenever we are saying that this material has some dielectric constant, that what is that mean? What we are actually meaning? Now there is an important point, like see. So whenever we said if there is a dielectric like this, let's say this is a dielectric. We said if we apply some electric field inside this dielectric, we will keep this dielectric inside the electric field, then what will happen? We said we will have some negative charge in this direction and positive charge in this direction. So basically why this happened? This happened because the polar molecules or the non-polar molecules like they are getting polarized because of the electric field. That means there will be a small separation between the negative charge and the positive charge. Now what will happen if we just increase the electric field? If we increase the electric field, then what will happen? The separation between the positive and negative charge will increase, because the electric field is applying force on the negative and positive charges. In the negative charges, the negative is getting attracted towards the left, whereas the positive charge is getting attracted towards the right. So that's why if we'll start increasing the electric field, then there will be a point when the force due to the electric field is so high that the electron will get out of this atom. it will like get out of the atom, and it will be a free atom. Then after that it will be a free electron. That means after some certain electric field, this electron will get ejected out from the atom, and now it will be available for the dielectric. It will be available as the free electron for the dielectric. That means after some electric field, the dielectric will behave like a conductor. That means after some minimum electric field intensity, the dielectric will behave like a conductor, and that electric field is known as dielectric strength. Okay, and when this happens, this state is known as breakdown of the dielectric, or else dielectric breakdown. This process is known as dielectric breakdown. That means at certain electric field, the electrons that were bound to that atoms will get ejected out from the atom, and they will be now available for the dielectric as free electrons, and hence they can conduct electricity. So after that dielectric strength, all the dielectrics will behave like conductors. But for different dielectrics, the dielectric strength is different. So we can say if you have a plastic, or if you are using paper into 220 volt current, into 20 volt potential, if you are using plastic as a insulator, that will not work as insulator if you are going to higher potential. If you are dealing with higher potential current electricity, then plastic and this paper will not behave like insulator. They will behave like